Hi, everybody. This is Dr. Maria Weber, and I want to talk about Jupiter. And we have Jupiter right here behind me. Jupiter here is tilted on its side. So over here, we've got one of Jupiter's poles, and we have Jupiter's beautiful cloudy banded structures on this side. This picture was taken by a spacecraft called Juno that's currently orbiting around Jupiter. And we have these beautiful swirling vortices that we can see in Jupiter's upper cloud layers. And these swirling vortices are a result of Jupiter's rotation and also the motion of Jupiter's atmosphere and its deep interior. I also want to talk a little bit about how big Jupiter is compared to our own Earth. So we can take 11 Earths and line them up along the equator of Jupiter. And Jupiter is really massive. It's about 300 times more massive than our own planet. And by massive, I mean if we just think about the mass of Jupiter and the mass of Earth, the mass of Jupiter is 300 times more than that of the Earth. Jupiter is the biggest planet in our solar system. Well, how big is it? It is so big that we could line up 11 Earths along Jupiter's equator. We could also fit more than 1,000 Earths inside Jupiter, and Jupiter is so massive that its mass is 300 times greater than that of the Earth. And then the next part of this video here, I'm going to be walking you through how we can calculate how many Earths we can fit inside Jupiter, and then I'll be asking you to do a similar problem to figure out how many Earths could fit inside one of the other gas giants, Saturn.
How many Earths could fit inside Jupiter? To find this out, we can take a ratio of the volume of Jupiter to the volume of Earth. Now, planets are essentially spherical, and the volume of a sphere is 4/3 pi r cubed, where r is the radius of that sphere. So, to find out how many Earths could fit inside Jupiter, we'll take the volume of Jupiter and divide it by the volume of Earth. So this equals 4/3 pi times the radius of Jupiter cubed divided by 4/3 pi times the radius of Earth cubed. Now if we look at this equation, we see that the 4/3 cancel on top and bottom, and also the pi. So we're left with a pretty simple equation that the radius of Jupiter cubed over the radius of Earth cubed is all we need to find the ratio of those volumes. And so if we do this computation, we will be able to find out how many Earths could fit inside the volume of Jupiter. Now, let's put some numbers in here. So we're going to take the radius of Jupiter to be about 7 times 10 to the 4 kilometers. And we're going to cube that. And we're going to take the radius of the Earth to be about 6.4 times 10 to the 3 kilometers. And we are also going to cube that. So if we go ahead and do this computation, we see that I did use the units of kilometers, but that's okay. We have units of kilometers on the top and the bottom, and those are both going to cancel with each other. So our answer is going to be unitless. Now, if you put parentheses around these large numbers in scientific notation into your calculator, cube them both, you will find that 1,300 or 1,300 Earths could fit inside Jupiter. This is also 1.3 times 10 to the 3 if you write it in scientific notation. So that's a pretty big number. We could fit 1,300 Earths inside Jupiter. So let's say that you don't have a scientific calculator with you, but you still want to do this computation. We can do it without relying on our scientific calculator as well. We practiced this a little bit at the beginning of the semester. So if we look at this number, we've got 7 times 10 to the 4, and we're cubing it here. Okay, so we can also rewrite this in a different way. So what you could do is you could cube the 7, take 7 and multiply it by itself 3 times, and you'll find that that number is 343. So we've got 343 times 10 to the some power. So here we've got 7 times 10 to the 4, and we're cubing it. 7 cubed is 343. Now we've got this times 10 to the 4, and we're cubing it here. So when we do this in scientific notation, what we can do is we can take the 4 times the 3, which would be 12, okay? And so 7 times 10 to the 4 cubed is the same thing as 343 times 10 to the 12. And I'm going to divide that by my number here on the bottom. If I take 6.4 times 10 to the 3, that's 262 times 10 to the what? Well, here I have, in my exponent, I've got 6.4 times 10 to the 3, and I'm cubing it. So if I take this 3 and multiply it by that 3, we get 9. And so down here in my number in scientific notation, I can write 6.4 times 10 to the 3 cubed as 262 times 10 to the 9. So that's 6.4 to the power of 3, that's 262, times 10 to the power of 9, that's our 3 times 3 right here. Okay? And so if I do that calculation, I can take now 343 and divide it by 262, and that number is 1.3. And then, whenever we divide numbers in scientific notation, we subtract their exponents. So my answer would be 1.3 times 10 to the, we've got 12 minus 9, so times 10 to the 3. And so then that still gives me my answer of 1.3 times 10 to the 3 Earths could fit inside Jupiter, or 1,300 Earths could fit inside Jupiter. Same thing, both of these ways. Now, the problem that I'm going to ask you to solve is to calculate the number of Earths that could fit inside Saturn. So you're going to do the problem the exact same way, except instead of taking the volume of Jupiter divided by the volume of Earth, you're going to take the volume of Saturn and divide that by the volume of Earth. To do that, you'll need to know the radius of Saturn, and we're going to take the radius of Saturn to be equal to 5.9 times 10 to the 4 kilometers. Okay? To use that radius of Saturn with our radius of Earth, which we're going to use as 6.4 times 10 to the 3 kilometers, in order to find out how many Earths could fit inside Saturn. And you'll do the exact same process, the exact same method to find out the number of Earths inside Saturn as we did right here to find the number of Earths inside Jupiter.